So in this video, I'm going to go through and explain the three different types of intermolecular forces that exist. Now, intermolecular forces are forces between molecules. So not within a molecule, like ionic or covalent, but between molecules. Okay? So the first type of intermolecular force I'm going to talk about is dipole-dipole attractions. So what happens in dipole-dipole attractions? If you notice in this example here, notice that hydrogen and chlorine, you have a compound here. Remember that chlorine is more electronegative than hydrogen is. Since chlorine is more electronegative than hydrogen is, if I were to draw my dipoles, it would look like that. Okay? So what happens is because chlorine is hogging the electrons for itself, it becomes partially negative. So that sign represents, this sign is partially negative. This side of hydrogen is partially positive because the chlorine here is hogging its electrons. So as a result, when you have a partial negative and partial positive line up, you have an attraction, and that attraction is called a dipole-dipole attraction. So in order to have dipole-dipole attractions, your compounds need to be polar. If they are not polar, you cannot have dipole-dipole attractions. The next type of intermolecular force is hydrogen bonding. Notice this looks a lot like dipole-dipole attractions. However, there's one major difference, and the major difference is hydrogen. In order to have hydrogen bonding, yes, your compound needs to be polar, but then also you need to have hydrogen, a hydrogen right here, and you either need to have nitrogen, oxygen, or fluorine. Okay? So if you look at this example here, you've got nitrogen here, hydrogen here. Hydrogen is partially positive because nitrogen is hogging the electrons for itself. The attraction between another nitrogen from a different molecule and this hydrogen, that is a hydrogen bond. Now, the reason why we distinguish between hydrogen bonds and dipole-dipole attractions is the fact that when you have a hydrogen and a nitrogen like this, because nitrogen is so electronegative, or because oxygen is so electronegative, or because fluorine is so electronegative, this partial negative is going to be really large. They're going to really hog those electrons, while that hydrogen is going to be really partially positive. So as a result, hydrogen bonding is stronger than dipole-dipole. So in order to have hydrogen bonding, you got to have a polar molecule, you got to have your hydrogen, and here's something that really trips people up. You've got to have that hydrogen bound to an oxygen, and it has to have another oxygen. There has to be an oxygen on another molecule that it's attracted to. So if this, for example, were, I don't know, chlorine, for example, and this were oxygen, this would not be hydrogen bonding because you've got to have this extremely partially negative and extremely partial positive charge. If you don't have that, meaning you wouldn't, if you had chlorine, then you're not going to have hydrogen bonding. All right? The last type of intermolecular force we're going to talk about is dispersion forces. So in dispersion forces, what happens? Electrons are normally floating around. There's no real order to them at all. But if they happen at one instance to line up on one side like they do right here, that's going to create a temporary dipole. It's going to be a partially negative charge. Well, if you have a partial negative charge right here, that's going to repel the electrons from an atom that's close by and force them to the other side because electrons repel each other. Therefore, what you've created is a partial negative and partial positive charge. That is temporary, but it does exist. So because you have an attraction between partial negative and partial positive, you have what we call dispersion forces, or London dispersion forces. That's another name for it. You can add a London to it for the scientist. Okay, so London dispersion forces, or just dispersion forces. Now, the question is, well, does it have to be polar? Does the molecule have to be polar for this to happen? And the answer is no. You don't even have to have a molecule. You can simply have an atom. So for example, this has, if you have 2 electrons, for example, here, or 3 electrons, you could have helium or lithium, for example, and this dispersion force would exist. So the interesting thing about dispersion forces is that it exists for all atoms and molecules. Okay, so if you have an atom, it will only have dispersion forces. If you have a nonpolar compound, it will only have London dispersion forces. If you have, for example, NH3 here, it's not only going to have hydrogen bonding, but it will also have London dispersion forces. But this, if I asked you what's the strongest type of intermolecular force, you would say hydrogen bonding, since hydrogen bonding is stronger than London dispersion forces. So let's look at a couple of quick examples to make sure we're clear on this. If, for example, I gave you chlorine, right? And I said, what is the strongest type of intermolecular force that this molecule experiences? Well, you first need to draw out your Lewis dot structure. Okay. Looking at this, I know that this molecule is nonpolar, which means that the strongest type of intermolecular force it's going to experience is London dispersion forces. Okay. What if, for example, I gave you pH3? Okay. So again, phosphorus has 5 valence electrons. Hydrogen has 1, but there are 3 of them, so it's a total of 8. So this is going to look like this. So since this molecule is polar, it's either going to be, the strongest type of intermolecular force is either going to be dipole-dipole or hydrogen bonding. Keep in mind it does have London dispersion forces, but that's not going to be the strongest. Looking at this, I want to say hydrogen bonding because there's a hydrogen here. However, because I don't have oxygen, nitrogen, or fluorine here, I cannot have hydrogen bonding. Therefore, this is going to be dipole-dipole attractions being your strongest intermolecular force. So let's look really quickly at all the different types of bonding and attractive forces that can exist. We've now talked about all of these. So you have dispersion forces, which are your weakest, your absolute weakest, because you've got a temporary dipole that's created. The next weakest is dipole-dipole attractions. Remember, your molecule has to be polar to have that. For hydrogen bonding, it's the next strongest. You've got to have hydrogen and either fluorine, oxygen, or nitrogen. Your next strongest up are now going to be intramolecular forces, so forces that exist within a molecule. So you've got covalent bonding here. That's your next strongest. And then the strongest that we're going to be looking at are ionic bonds. Notice for all of these guys, you've got a partial negative or a partial positive charge. When you have an ionic compound, because, for example, here, sodium is donating an electron to chlorine, you have a complete positive and a complete negative charge, which is why ionic bonding is your strongest type of attraction that you can have.